Hello, everybody. How's it going? Is this working? Let's. Oh? I don't know. Yeah, okay. Looks like it's working. This is not a demo. This is just me programming. I have been away from all computers and written material and everything for 11 days, and we'll see we'll see if I can program at all. So while I've been gone, there's a couple things that I've wanted to do. One of them was to go clean up some things in the polymorphism system because, well, I've demoed a couple of different sets of polymorphism features that you can see on YouTube if you want to go back and watch those. And by the time I got done with the second one of those, and I felt like it was a mostly feature complete system, the code was really complicated. And I realized at one point, oh, I'm kind of scared to touch this because things are going to break all the time in weird ways, and it's painful when that happens. So about, I don't know how long ago now, 6 or 8 months ago or something, I did a drastic rewrite of the polymorphism system, and that was very successful. I was no longer scared of it after that. It still had all the same features, but it was much cleaner and easier to understand. But even after that, it is still one of the bigger and more complicated systems. And, well, part of what happens over time, part of the reason I'm designing this compiler by implementing it is that, in the process of implementation, I gain a clearer understanding of how things should be. And so, there are certain things about the implementation of polymorphism that are complicated, because I had to support certain things that I wasn't sure were going to make it into the final language or not, but let's try it. There are certain invariants that I didn't want to put in place because, maybe that'll get in the way of a feature and stuff. And so what I realized over the past 10 days, one of many things I realized, is that enough decisions have been made in how this stuff should work that I can just kind of go in now and harden and make the polymorphism stuff better. Now, the first step in that, though, is going to be to get the old demo working. So the Sokoban game uses lots of polymorphism, for sure, but it doesn't stress case every feature. So what I'm going to do is go back and get the first polymorphism demo running again, which, it doesn't run anymore because, the syntax of the language changes and things in the standard library change, and I'm not going back and maintaining old code very often unless I need to. So this is going to be an opportunity to go do that. And then once I get that demo working, or mostly working, so it's possible when I try to get it working that a couple of the advanced, more corner case features that I'm not using in Sokoban just won't work at all. And if that happens, then I think I'm going to leave it broken because, or those small parts of the demo broken, I'll comment them out. Because the changes that I'm going to make today, if I can remember everything I wanted to do, are going to be far-reaching enough that they might break that kind of thing anyway. So kind of what I'm looking for is to do some basic, get enough of the demo working so that I have two programs that, okay, so Sokoban is one program that uses polymorphism, and this demo is the other program that uses polymorphism. And at any time that I change something, right, I can compile and make sure both of those run. And this is not the same as having a super rigorous regression testing to see if your new compiler change broke anything anywhere, right? But it's pretty good, and for my current purposes, it's good enough. So I have this sort of like poor man's, lazy man's regression testing by having these two different programs. And so, you know, anytime I'm going to do a new thing, if I think it's just an optimization, for example, then I type it in and make sure it runs in both those programs, and that'll be good enough for me to check it in. Yeah. So are there any questions about that? I don't quite want to start for another couple minutes because I've got to eat a little bit of a snack. I don't have fun snacks. I've just got old cashew nuts and fruit bars. So I'm probably going to stream a couple times today. This first stream might be short, just like an hour or two. And then I'll take a break and get some real lunch and some snacks. And then I'll probably stream again tonight. Ginger Bill wants to ask a compiler design question with regards to parametric polymorphism. Please do. Dude, I like this shirt. This is a brand new shirt. It's the first time I've worn it. I should make a collection of special live streaming shirts that I only wear when I'm streaming. While I'm waiting for the question to come in, this is the old demo program that I showed way back, and I'm going to start working on it. For example, the update build options command is changed. So, you know, if I go and I tried to compile just before the stream, and it's like, oh, undeclared identifier update build options. Because it's not how it works anymore, there's like a set and get build options. And since I'm not going to do any of these right now, I'm actually going to comment that out. Because it wasn't doing anything in these. The reason that this was here was just if I set any of these flags, then we want them to take effect. And the way that you do that now is slightly different. You get the build options and set the flag and set build options. I do tend to have shirts that play in areas that a lot of people don't wear that kind of shirt. Yes, it's true. You're halfway through If Honor Winter's Night a Traveler. It's a short book. Just finish it and then watch the talk. Actually, we're probably going to, in the next week or something, I'm going to post a recut version of the talk that has the slides like cut into the video that someone's doing for us. And that'll make the slides more legible. So if you want to wait a week, that would probably be the better time to watch the talk. Have you ever met Mark Cerny? Yes, I met Mark and had dinner with him and some other people during the PlayStation 4 launch event in New York in, was that 2013? Whatever year that was. Oh, and also at, I feel like some other Sony event as well. How do you type check a generic procedure? I'm self-taught, so I don't know modern compiler design. And what I've learned is to map each AST node with a specific information, one-to-one mapping. how do you extend that to parametric polymorphic procedures, or do you do a different method? No, so what I do is really not going to be surprising to you. So for type checking generally, it sounds like what you do is exactly what I do. So you have a syntax tree, and there's some pointer on every node of that tree that's like, okay, what type is this expression, right? And you know, when that node is first constructed, that pointer is null because you don't know, right? And when you go through the type checking pass, that pointer gets set to something valid, right? And if you can't find something valid to put there, then that's a compile time error. Okay, so the only difference is polymorphic procedures they sort of exist in two phases, right? There's a version that has not been instantiated yet. So it's just the declaration. Let me find one in this file, right? Oh, demo poly. So where's the, okay, so here's my sum with an array of $t or whatever, right? We don't know if whatever t is going to, if plus equals is going to be a valid operation on that type, right? So we can't really type check this. And so when it's uninstantiated, I don't type check it, actually. It just lives somewhere, right? I did, for a while, play with the notion of trying to type check, like search for information in here that doesn't depend on the types and try to type check that only on the parameterized types. But that didn't seem worth any of the complexity that would have been involved. So I don't do that at all. So what happens is I parse this, and then this goes through the type checking pass, and some things happen to it that are relevant for processing polymorphic procedures, but it doesn't go through the regular type checking that everybody goes through, right? Then what happens is, when you call this guy, so you say down here, you say, you know, sum of A1, and then we match this. Now we know all the types, and we can instantiate this procedure. So I just copy all the nodes. It's just, boom, copy everything. And then I can tweak the nodes and put type values on them and all that stuff. And there you go, right? There's no mystery to it at all, right? So I copy it. So this original polymorphic procedure just lives as you would expect, unmodified, and a new one gets created, and for each of these cases, right? Now, of course, I do duplicate detection, right? So if I see that I'm calling sum with a type that I already instantiated, then I just use that instead of recopying the thing every single time. But, you know, aside from that, it's exactly what you would expect. So it's really not a smarty pants thing at all. There's, you know, being able to copy this thing correctly requires a certain level of, you know, your code has to be up to the task. We'll put it that way. And that was one of the reasons that polymorphism got complicated is, you know, before I implemented it, all my data structures were set up to be without polymorphism. And so some of them were, you know, factored in a very inconvenient way relative to this feature. And so as I figured out what was inconvenient, then I would work on that and rewrite that and all these things. So it's really, yeah, basically I make a non-polymorphic procedure out of it, and then I type check that every time. Yeah, no, it's the most obvious thing. I just copy it. And actually, if I'm successful enough, if I can actually program after having meditation brain for 10 days, then what I'm going to go do today is clean up some of the code involving what the variable parameters are, the type variables and stuff, and unifying that and simplifying it. So originally, let me try and find, this demo was so long ago. There was one of these. baking, modify basics. Is it in basics? Basics sure is long. Okay, anyway, I don't know where it is right now. Maybe we'll hit it when we compile. But there was one of these procedures where in this demo, instead of, maybe it was in a second demo, but instead of having a parameter here, instead of having this type mentioned in the parameters or the return values of the procedure, it was just like randomly inserted down in the body of the procedure. And I thought that was an advanced feature at the time. I was like, hey, that's great, because it doesn't, you know, oh, it's maybe in the bake demo, because you have to bake it in order to use it, because supplying the arguments doesn't give you enough information. Yeah, here, this one. So here I just say, oh, y is some type, right? And it's going to be equal to x. And so I can't compile this. Just by calling arguments, I have to bake it, right? Now, at the time when I did that, I was a little bit wary. I was like, well, in a large procedure, I don't know if I really want one of these to sneak in like 100 lines down into the body of the procedure, because it's going to be hard for someone to come along to understand when they're reading the program text. But also, it might be easy to make a mistake that way. Maybe you typed a $ for some reason, and I don't know. So I was thinking about that, and I was like, is this really going to have applicability? Is this a good enough feature to make it worth any problems that it might have? And then in the intervening time, since I originally programmed that, I realized that this introduces a lot of complication. Because the thing is, the way, this has a little bit to do with the way the compiler is structured, but what happened is you can't actually know, or the compiler can't actually know, that the procedure is polymorphic until pretty late in the pipeline, because it might find something in the body that's polymorphic, and that might bubble up through arbitrarily nested complex expressions, right? You might just say, well, can it scan linearly through the thing and find something polymorphic? But that's not really how it works. So it had to sort of wait until the end of type checking to know if the procedure was polymorphic at all, which may not completely make sense if you try to square it with what I was just saying, but because it does go through type checking in principle, but what happens is when something polymorphic tries to get type checked, it gets a special type that says, I don't know what type it is because it's polymorphic, and then what happens is that bubbles up to the top of the procedure, right? So on the one hand, it doesn't get type checked normally. On the other hand, I do all that bubbling up right now, and that takes time. Hopefully the majority of your procedures aren't polymorphic, so it's not too much time, but it's still a little bit annoying. But it also complicates the compiler, right? The more information you have about something, the earlier in the pipeline, then the less you even have to worry about when you're programming on the compiler, oh, do I have this information yet or what, right? So what I want to do is I want to outlaw this. And the reason I want to outlaw this today is that it's probably much more programmer friendly, both for the person writing it and for people who come along later to try to understand it, to do something like this now, right? And put it in the parameter list, but instead of being a type value, it's like a precompiled value. So this single $ here is this used to be the syntax for that for people who have seen the previous demos, including this one. So one of the things I'm going to have to do is change the syntax. This is now simplified to just that. So if there's a $ on the right in the type slot, then it means the type is the thing that you match. And if there's a $ on the left in the value slot, then it means that the value is the thing that you match. And because this value is of type, then we're good, right? Oh, I still need to say, sorry, I deleted this. This should say just without the $, right? So that way you can come along, you can know if the procedure is polymorphic just from looking at the header. The compiler knows it as soon as it's parsed the procedure, which is very early in the pipeline, and that's good. And it's so, you know, I should be able to remove hopefully hundreds of lines of code because there's all sorts of messy stuff like about whether something is polymorphic. Yeah, we'll see. We'll see how well that goes. Yeah, I mean, the thing is I do effectively have explicit type parameters now because types are first class in this language. But that was not true. Like back when I did polymorphism, we didn't have first class types in the same way, right? That demo came later. And so now that those decisions have been made, it's like, oh, okay, that helps simplify the polymorphism thing. And so if I can make polymorphism less scary, anytime I can make polymorphism less scary, it's a good thing. So I'm going to try and do that. That said, again, the warranty or the disclaimer is that I may not be able to program at all today, right? Not only has it been 12 days since I touched a computer, but I've been doing weird things with my brain for those 12 days. And so who knows? All right. Check in the chat. Why not move this outside the parameter list? Because you don't want your caller to have to think very hard about whether your procedure is polymorphic or not. Right? In C++, you have this kind of crap where you say like template, type, name, blah, whatever, right? And I mean, sometimes in C++, you end up not having to think about it, but actually a great deal of the time you do, right? Whereas in this case, the goal is you never have to think about whether it's polymorphic or not as the user, right? So there's just some parameters. I might have 3 overloads of this procedure that all take 2 arguments, an x and a sum type, or I don't know, an x and then a second value, and one of them is an int, and one of them is a float, and then this one's a type, and only in the case when it's a type and do this. And I want those 3 to be like overloads that are associated with each other and all that. And if I have to radically change the way that I declare things just because this one is a type that I want to know at compile time, that's annoying. And it causes you to like refactor the syntax of your program. This is actually very simple. If you're not used to it, you know, it's just you're not used to this language, but it's actually quite fine. Yeah, upgrading your brain once in a while is a good idea, especially as you get older. Okay, could I go once more over the differences? Okay, so someone's asking about the difference between this and this, right? So let's do it in the case of a value, first of all, right? Putting $ type here would be misleading because this isn't a type. What the $ says is, okay, so first of all, anytime you have a declaration, right, it's the name on the left and then a colon and the type on the right. So what we're saying here in this version is the type is a variable. It could be anything. So let's call it, you know, Z or something. We don't know what that is. We could capitalize it if we're going to do like the C++ convention, right? So Z is some, well, see, we have to change both the names because we don't, the whole reason that you do this is that you don't know what type the thing is. So calling it a type, it's probably not a type, right? It could be a float or an integer or something. So I could say, here we go. I'll say Z is a parameter and it's type of Z, right? So when I pass, whatever Z I pass in, if it's a string, right, then type of Z becomes string. If this is a float, then type of Z becomes float, right? And so then if I say type of Z equals X, right, etc. So this is when I want to do different stuff based on the type of this thing, okay? This is when I want to hard code the procedure for the value, right? And instead of doing it based on a type, let's put that aside for a second because it's probably a little more confusing to think about types. Let's just do it for an integer, right? So I could say n is an int, right? And then I can say for 1 to n, print high, right? So what happens is when you call this, okay, n is always an integer, right? So if you call it with a 7, then it'll be baked into this procedure to do for 1 to 7 print high, and then maybe the compiler can unroll that or whatever because it knows the parameter is fixed at the calling site, right? So, and then, so when you do this version that's just some type, it's just like n being an int, but it's just some type, and I happen to know it at compile time. So if that's still confusing, you know, there's 2 hours of polymorphism demos on YouTube that you can look at. Someone is asking, is this like in C++ where you can't use generics without having the full source code of the template definition? Then, yes. However, it is not like C++ actually, because this language is way, way better than C++ in many ways. One of which is you don't ever include the source more than once, right? So, you know, when you, it's you know, module semantics inclusion or something. So the source for this only gets parsed once. You don't have all the weird compile time problems that you have in C++. Secondly, the fundamental philosophy of this language already is that for many compilation features, not just polymorphism, you will always be effectively compiling from source because that lets you do a lot of things. Like I can take a procedure that was not declared to be polymorphic, like this one, and I can, at a calling site somewhere randomly in a program, bake me a version where x is 10 and just flow that through the thing and do whatever you need to do to make that happen, and that'll just work, right? You can't, well, I'm going to show some even more advanced things maybe in a month or something where you can edit the bodies of procedures internally in certain ways from the calling site of a function, right? So all those features are super valuable and you don't want to give them up. And so a big part of the pain in C and C++ is this whole object file paradigm. I think it's a bad way to do things. And so we don't do things at all. When you compile a big program like Sokoban, it's 50,000 lines, we don't make any intermediate object files. We just make the output. So what happens if you want to do like a closed source library that's, you know, your commercial trade advantage, and you don't want someone in China just like stealing it and doing small modifications and copying it and reselling it. We will have something for that, but it won't be exactly an object file. It'll be more like a streamlined, packed up, potentially slightly obfuscated, fast to parse format. But it will still have all the power of source code when it comes to performing these kinds of features. Do I foresee a compiler mechanism to actually unroll the generic so you can walk through specific cases of the generated code in the debugger? It already works that way. Well, the one, okay, so we don't, well, for certain classes of the language features that are kind of like this, like the body text kind of stuff that I demoed originally in this and sometimes at other times, that text gets, yeah, you know, it's, okay, so what I'm thinking about that makes this answer hard is an intermediate feature that I haven't demoed yet. So let me take that out of the answer and just say, for body text kind of stuff, it already saves the text in a file somewhere, so your debugger can just be pointed at that text, and you'll be able to see what the code is, and it'll just work. For stuff like this, all that happens is these variables get baked at different values, so I don't think you really want to see 20 different versions of this source code. Maybe if you did, it would be more like a compiler operation, but what, or an IDE operation, but I don't think you want that. I think you just want to hover the cursor over type of Z and say, what's type of Z for this particular call that I'm in, and then it would tell you, right? And the intermediate feature we'll talk about when we demo that. Okay. Well, this has been a lot of stream questions, so why don't I then just start trying to program and see what happens. So, all right. So there's lots of things wrong, probably. Unexpected end of input in code block. That's not a good one. I need a better error. I need to implement better error checking than that. I'm not going to do it right now because I don't want to sidetrack, but somehow a block ended early, which probably means, it probably means I started a comment somewhere and didn't finish it or whatever. It thinks baking. Did I save a modified version of this procedure? That matches baking. Okay, wait. Oh, yeah, I saved it. Duh, there's all this stuff. Well, someday I will tell you where the scope started. That would actually be a trivial feature to implement. I just haven't done it. Oh, it's still samey. Wait, what? Oh, because I have this. Right. Size in bits is not a member of type info integer. So these were some fields that were in the type infos, and they were redundant with a field called runtime size. So I'll update that. Info.runtime size, and this is in bytes instead of bits. So same thing. I might do this like 5 times in this demo. I don't remember. It's kind of fun to just sort of be remembering this demo, like when I did it. Size and so many size and bits. How many do I have? Oh, that's it. Okay, type.runtime times 8. We go from bytes to bits. Oh God. Okay, this is what you don't want to see when you start live streaming. It was a little bit risky for me to go back to a really old demo that has a lot of weird corner case features. This is circular dependency errors are usually a compiler bug. And I don't want to rat hole on that now. It is something that I want to fix. This is not supposed to be a user-facing error, right? This is like, oh God, something bad happened. Let me see. We can look at, okay. So we're trying to run this run directive. It's calling probably, I don't know, let's go. We're trying to run main. And main, well, no. Main probably depends on something that's not in this list. Bake values is depending on print names and values, which is depending on spacing mode. Okay, I feel like there is a bug where if this is at local scope, yeah. So this is probably a bug that's actually being caused by the kind of thing that I want to clean up today, and this is why I want to clean it up. I think maybe if I move this to global scope, this will just work. Let's see if that's true. Okay, well, it didn't circular dependency on me. Okay, so I'm going to put a note here. After polymorphism demo is done, or cleanup is done, make sure the program works when this is moved internally to break values. So, you know, basically, because this guy had a locally scoped procedure that was polymorphic, it was causing the outer procedure to be held up for some reason. And because then this was situated in here, this was also being held up, and it's a bad scene. So, you know, this is why I want to go in and simplify that stuff so it's easier to debug this kind of problem and fix it. Right, so we got rid of .strict for enums, so we just get rid of that. Members. Okay, so there used to be this thing in an enum where I would make these sub namespaces, and that is no longer a thing. What do I do on that? I say wait, what? Right, on an enum we don't do that. So there's something. Okay, so I have a couple of helper functions to get the names of enums and stuff like that, because I found that to be more useful. So let me see what I was trying to do here. Using spacing mode. Oh, this is just using, forget it. That's just that. Okay. Well, we got kind of far, and then we crashed. Baking. So we call using test on a vector 2. So it's the bake directive that is not working yet. I'm going to not worry about that, because the bake directive is one of the things I want to clean up, I think, and rename and all that good stuff. So I'm going to say that I'm going to start doing this cleanup work. Let me change this. I'm going to start doing this cleanup work, and as long as the program gets to here, actually, okay. I'm going to print something. I'm going to say print incomplete fix bake in this procedure before you are done, right? So, you know, before I feel like I'm done with this task, I'm going to search this whole file for incompletes and address them all. And let me just return from this procedure. We'll see if we can run the rest of the program. Because, you know, working on bake can get complicated and stuff, and it'll get simpler when the system is simpler. Okay, so the rest of the program works. So that's all good. I could even, I don't know why it seems like this is a very simple thing. It's probably a very simple bug having to do with like, yeah, it's something very small, but, well, let's do it. Let's look at what the crash is, because I feel like it may be simple. And that'll be a good way to warm me up. Any questions about what you're seeing right now? Any questions? I went through all this whole demo way back. So all this cow, horse, llama stuff, I explained what it's all for. There's tons of that on YouTube. All right, so I'm going to say we're going to debug. All right, so we should be able to run this. Okay. Well, so this is running in bytecode right now, right? Because I'm running it in the compiler. And, well, we're trying to call a procedure that is not a valid procedure pointer. And I feel like probably what happened is the bake is supposed to return a validly baked lambda, and it's probably giving us back some junk. Let me just see. Or it's just, actually, maybe the bake is returning something good, but the bytecode instruction that we're creating is doing the wrong thing now. Let me just see, BC. So every bytecode instruction is a big fat thing. They're much bigger than they should be. So I can go, I record tons of stuff. So this is being generated at line 3956 of a certain file in the compiler. So I can go to bytecode builder 3956. So we're making a calling record. Yeah. So if the proc register is a certain thing, then I put a lambda. It obviously must have not been -1. Because this would have resulted in a valid lambda being put in that struct. So it must have been this. But even then, like, the inferred type of the expression should have been, you know, it's possible we're just trashing memory, but I can look at, so this bytecode has a serial number, and if everything is being correctly reproduced, what I can do is I can go to bytecode builder line 3956, and I can set a breakpoint, and I can say break here when the serial number is equal to that. Whoops, I want to stop and restart. So we're running from the beginning, and here we are again. Okay, so proc register is 3. So as I thought, what's the expression? It's an identifier. So I'll cast it to ident. So it's baked 3 that is crashing us. So we can go to that in the program, just yeah, it's indeed this thing right after. Right. Okay, but this isn't the line that's crashing. This is the line that's crashing. So, you know, the difference between this and this, it's not actually the polymorphism exactly, right? So both of these, this is polymorphing the procedure for a vector 2, and this is polymorphing the procedure for a vector 3, where we're assigning it to something, and then we're calling it through the identifier. And what's going on is this thing doesn't handle when it's an identifier correctly anymore. It's one of the things that broke, because I probably don't do this in Sokoban, and so it broke. So let's see if it's easy to understand and fix. If it isn't, then I'll postpone it until later. My microphone is directly touching the surface my mouse is on. Yes, it is. Sorry. Can I move the microphone a bit? All right. The other thing is actually I've got a cable. Let me unplug the mouse cable because I was charging my mouse. Let's see if that helps. Let me try to put a pad under the mic. piece of cardboard. I don't know how much that'll help, but we will find out. It's a little bit difficult because I want the mic to be in front of the monitor somewhat, or things will get muffled by the monitor. Let me try putting it off to the side a little bit more as well. Back in San Francisco, I have a huge office desk, and my desk here is not quite so big, but we will see if this helps. How is this? I'm mousing right now. Is this any better, or is it terrible? I can also move the microphone a little further back. Who knows? Yeah, I just don't have a very, I don't have anything to hang anything from right now. The mic is one of these standy guys. Does it have a hole on the bottom? Not really. Sounds scratchy. Well, how about if there's like a pillow or something? Let's see. Okay. How about this? I'm mousing. It might just be the sound of the mouse. Like the mouse on the desk makes a certain noise. Yeah. Yeah, Visual Studio's font is pretty small. I guess I can... Yeah, this still works. Is that better? Oops. Why did I click the wrong box? Okay, good. I'm glad the sound is much better than before. Okay, so... I feel like this is just an old code path that is no longer what that bytecode instruction expects. Big classes, options, proc register. Okay. So basically this is saying, look, if the options is not -1, then it's a register number, and you should use that for the value of the lambda. And maybe it is doing that. So let's make sure it's doing that. It probably is, honestly, because that's the only way I could think of to. Okay, so this is all kind of working. It's not foreign. And we didn't have a lambda yet, so we're getting the value out of the register, and that value is 19. I feel like, okay, so I feel like the bake just returned a bad value, right? Which I think falls in the category of it's fine. I mean, it's not fine. It has to be fixed. But I think that's a category of thing that I will fix after I clean stuff up. because bake is going to break anyway. And yes. I feel like it may even just like not be, okay, wait. You know what, screw it, because looking at a call to bake will again help warm me up. I haven't looked at this code in a while. So if I say, I want to say, let's look at this bake call that's on line 484, and let's just make sure that it returns the right value. Oh. I don't even remember exactly what to look at. It would be in type checking that this happens. So we look for directive bake. I think it's, no, it's here. So there's a giant switch statement here that happens when we type check things. And so here I just want to say line 484 will break here. Are we going to get our own debugger? So a mildly off-topic question. I guess you don't want to use the Visual Studio Debugger forever. Is it going to get cool features as well? Well, I would very much like to have our own debugger. I mean, I think we will start with something more like program visualization tools. So you can see, you know, how your code is structured and things like that. And then once you can visualize your program in a cool way, it may give new ideas for how to debug. Prior to that, though, that's a long-term thing. Prior to that, we do have Visual Studio support when you compile with the LLVM backend. So it's not perfect yet, but it's, you know, it's getting better. And yeah, so that's the short-term plan, is to just use Visual Studio or GDB on Linux or whatever. Okay. So, okay, this is not good. We didn't hit that breakpoint. We hit our bytecode breakpoint, which is supposed to be later. Well, I don't know why that didn't happen, but let's just stop on every bake directive, because there shouldn't be that many. And let's just see. See, I don't know how to raise the font size of this in Visual Studio. I should be able to just control click just like in this window, but I can't. Oh, not like number. Line number 483. Why is it line 480? No, it is 483. See, I did this. When you do this in Emacs, your cursor ends up on the subsequent line, and that's 484. Duh. Okay, let's just change this. 483. Okay. Okay, so the identifier resolved to something. That means, okay, we found a using test. Now, using test may point to a list of overloads as opposed to just one procedure, right? So it's not a dynamic specialize, it's a regular bake. So let's eval to literal or constant, which should give us back a lambda. Expression type is a lambda. I don't know how to raise the font size there either. Okay, so I don't know how to get rid of this stupid thing. Lambda is a static cast now, so that'll point to the correct thing. And it's not a value bake. So that's just error checking. But now we have the value of lambda. So now we're doing, let's look at what our argument values are. So we're passing a vector 3 for t, and it's in a named way. We didn't have to name it, right? We could have just said this, but we did name it. So, right, if we look at the name, it's T. I don't know if you could see that in really small print there in the middle of all that spam of zeros, because Visual Studio is terrible at showing you values in 64-bit mode. But yeah, so that's T, and the expression is going to be the value, and that's going to be, if I dereference that pointer a couple times, it'll give us a struct vector 3. Okay. Whoops, I accidentally set a breakpoint. Did I accidentally clear the, no, that one's there. Okay, is this correct? Wait, what? Why did it? Okay, well, at least that really is a type instantiation. Okay. Well, whatever. Item.value. So it's a type, and it's a type definition, and yeah, I mean, if we dereference that, that'll be the vector 3 type. All right, so that's all good. That's working. See, there's all these if statements in here and stuff that maybe I don't need. Like the difference between a value bake and not a value bake probably shouldn't really be a thing. And part of what I'm going to be doing is working towards simplifying that. Okay, why are we still in this loop? Right, we only had one. What? I don't understand why we're still in this loop. Oh, this is a different loop? Right. So the loop we were in before was this one, which is just setting up the items, right? This loop is, we're looking for constant expressions for each thing. So in this case, the type vector 3 is a constant expression because that's a compile time thing. Vector 3 is not going to change at runtime. The concept of what a vector 3 is will not change at runtime. You may have many different vector 3s, but the concept of that type and what its members are will not change at runtime. And so that's a constant expression. And we're looking for the value. And also looking for the declaration in the lambdas types block where we're going to put the value. And then we're gonna poke that slot, right? So we find the right declaration in the block. Any polymorphic variable goes in a special scope in the lambda called the types block, which is, I may have shown a diagram of this way back at some point, but it's one scope above the arguments, but before the lambda's parent scope, right? So you can swap in polymorph variables at that location. Maybe that'll eventually be simplified to the arguments block. Let me make a note of this. Simplify types block into scope as arguments block, maybe since all polymorphic variables need to be in the lambda header now. So the reason to have them as separate scopes is you might have a name collision, right? You might have a polymorph variable and then an argument with the same name, which seems like a really bad idea, but you know, it could happen technically. However, now maybe that can't happen, and it would simplify the compiler a little bit to have fewer scopes, but I am not sure if this would be annoying with regard to names of return values colliding or not colliding with polymorph variables. Anyway, it's a thing to think about before I'm done. It's not urgent to think about that now. Okay. What were we even doing? Okay, so whatever. I feel like this is all going to do some things. So we get back a poly lambda, and yield is null. So it gave us back a correct lambda, right? So if we look at this, poly lambda is just going to have a bunch of stuff. It looks reasonable. All these pointers are set to things. Again, sorry about the zero spam, but it's Visual Studio being terrible. So we set that as a substitution. So every expression in the syntax tree node has a slot that you can put on, if you const expr evaluate something to a simpler expression, for example, it can go in the substitution spot, and then a later phase of the compiler uses the substitution instead of the expression itself. So we set that, and okay, that all looks like it is doing the right thing. So if I look at expr arrow substitution, yep, that is all correct, I think. So what is wrong then is going to be, now that I'm in the middle of debugging this, I'm just going to go all the way, because I feel like the problem is not anything to do with polymorphing. The polymorph worked. So the problem is just whatever the bytecode is doing, maybe to assign that register or to use that register, right? So here's what I'm going to do. We're going to go tilde crash. Right, so remember this was an identifier. This expression, right, if I remember correctly, was, baked 3. So what I'm going to do is I'm going to go to this declaration that assigns this lambda to this variable. And I'm just going to see what the hell that does. And actually, before I even do that, let's see if something really fundamental is broken. So for example, I'm going to have a foo. So super simple procedure is not polymorphic or anything. And I'm going to say proc is foo, right? And proc 5. So I want to see foo 5 in my output. And the reason I'm doing this is I'm assigning this procedure to a non-constant identifier, right? This would be assigning it to a constant identifier, and I'm pretty sure that would work. If I put it in a value like this, maybe that broke. I feel like this is something that I probably do all over in Sokoban, so I don't think this will break, but I want to know. Wait, incomplete. Really? So that is broke. That has nothing to do with polymorphism at all. Okay, well, that's stupid. When I upload this to YouTube, I'm going to call it before doing anything regarding polymorphism. Okay, so basically, when this works when this is a constant declaration, because it gets const substituted. When you say proc of 5, it just makes it into foo of 5, relatively early in the compiler pipeline, right? When you do this, that mechanism doesn't engage, and it's like, well, they might change this, so this isn't a const. And so when I run the code for this procedure call, I have to do the right thing. And actually, really, when I run the code for this declaration, I have to do the right thing. And it's probably this that is broken. Yeah, Juan has been doing debugger stuff for a while, so you could ask him about dwarf. Have I already been in Germany? Yeah, I've been to Germany like 5 times or something. I've been to I've been to, well, Cologne a couple times, or at least once. Why am I not remembering the name of this other city? Some other city. Freiburg, Göttingen, or however you pronounce that. I should know because I've been there twice and I still don't know. And somewhere else. Hey, Sean. Yeah, you know, so that's the thing is so again, like I said, a custom debugger is relatively far in the future, but I am so annoyed at the current debugging formats, and they're really limiting, honestly. Trying to fit something into Dwarf, for example, or Cough, or anything, like, I mean, they're formats that were designed many decades ago, and it feels like it, right? And so then even, you know, so Microsoft has its own, like, you know, expanded debugging format, and even that, it's just not good. So what I would like to see, well, I don't know, we'll see. But, so before we even talk about a debugger, we're going to end up with a compile time metaprogram that just dumps helpful information about your program anyway, right? Like for the editor, it's probably going to be the first thing. Hey, let's dump all the information that you need to syntax highlight in your editor. That's more information in some sense than you need for debugging in terms of volume, right? It's just of a slightly different nature. And so once you have that, it's relatively easy to imagine expanding that. And doing that in a custom file format, I feel like is easy, right? And so, yeah, we'll see. We'll see how it goes. Pronunciation of Göttingen was spot on. Okay, fine. I don't feel like my German is particularly good. How did I see that the crash was caused by colon equals when the program crashes anyway? So it's crashing anyway, okay. It's crashing on this bake, right? But if I do this, let me do this down here. If I return and I change this to constant, the program will not crash now. See, we completed. If I change this now, because remember we had two different crashes, and it gets confusing when you have two, right? All I have to do is change this to an equals, and it'll crash. So it's crashing on this, and it is, like, honestly, it's a really dumb bug that has nothing to do with polymorphism, and that I wasn't hoping to do today, but maybe I will just do this bug, and then take lunch, and then start working on polymorphism, really, which is fine, because, you know, looking at that code a little bit brought it back into my memory a little bit. All right, so I need to make sure. Oh, the other thing to test. Oh, I can't. Okay. Let me see if this crash is only running in the compiler or if the executable crashes also. Now, this is confounded by the fact that the executable might crash for other reasons. So first of all, let's comment this out completely. It runs in the compiler, and now I should go test demo poly prebuild.exe. Okay, well, what the hell is that all about? Oh, in pre-build. No. Oh God, there's an SOA thing. Okay. SOA is deprecated for now. We will likely be introducing an advanced feature that replaces the way SOA has been done. So I am letting stuff like this break for now. Okay. Whoops, gotta recompile. Okay, so without the SOA part, all of that works. Now, the thing is that lambdas are a slightly different thing in the compiler than they are in executable code, right? In native executable code, they are always the pointer to the memory address of the procedure, just like they are in C or C++, right? Bytecode is more managed than that, right? So in bytecode, they may be a pointer to the procedure. If it's a foreign procedure, like from a DLL or something that's written in C and all you have is the pointer. Otherwise, if it's from your program, then you have a complete lambda struct with all this stuff in it. And the reason is because there's not anything else. You know, when we're running in bytecode, we haven't compiled to an executable. So, you know, so what I'm going to do now is just see whether this, so, okay, we know that this crashes at compile time, but I want to see if it crashes at runtime. So I'm going to take out the run main here. So now we're just compiling, whoops, we're just compiling the program, right? I don't know, I should have looked at this warning, but I don't want to push too many weird tasks on the stack. Okay, so we compiled. And let's see if it runs. Okay, so it crashes the same, seemingly the same, in both compile and in both bytecode and native code. So that gives us some information. It says that maybe it's not due to the difference between bytecode and native code, right? Maybe this is just messed up. So what I'm going to do now is I'm going to find a breakpoint. Well, for this, so let's just run to here again, because I want to make sure that I didn't edit my program enough for my serial numbers to change, which I did. All right, what line number? Oh, right, because I moved this down and stuff. So we have to re-find our, oh, no, I'm not, okay, never mind. I'm going to say, just when I'm emitting code for a declaration on line 481, I'm going to break there. And hopefully there won't be too many. There might be line 481s in other files, like library files, but there won't be that many because it's a simple program where we're not loading many libraries. So I should be able to find it pretty quickly. So line 481 and emit code for declaration, maybe. Let's just see, let's set a breakpoint here and just see what happens. Decal line number is equal to 481. See, I don't, even little things about Visual Studio annoy me. Like when I started running it, this breakpoint grayed out for a bit as if it was going to fail, which does happen sometimes. It annoys me. And then it comes back and it's like, you know, that kind of thing. I mean, Visual Studio is so messed up in other ways that I can never expect them to get back to that kind of detail working properly. But it's just little things like that that degrade quality of life. Okay. Okay, so let's see decal file name. Okay, it's the right one. Decal identifier name. It's proc. Good. So let's see what we do here. Do placed assignment. Okay, well, this is already making me slightly nervous because placed assignment is an optimization that prevents us from generating too much bytecode, but let us soldier on. Okay, so we make a placement. A placement is just like, you know, if something's going on the stack or in a register or something. Yeah. Okay, so what is our expression? an ident. What? That doesn't make sense. Foo. Oh, right. No, it does, because we're not doing the bake anymore. We're doing this. So this is fine. Mini series of dedicated rants. Maybe I'll do that sometime. It's just that when I go into full-on rant mode, people get on my case about being too negative. So who knows? Are there any alternatives to Visual Studio that I would recommend? No. Visual Studio is the best compiler and debugger on Windows right now. I mean, maybe you can compile with Clang or something if in certain cases you want better code generation or whatever, but I'm not up to speed on what things Clang does better code gen-wise than Visual Studio, if any, because I believe they just improved the Visual Studio compiler again for 2017. This is 2015 that I'm running. But for all-around workflow, this is still the best thing that I know of to use by far, which is sad because it's a pretty crappy workflow, honestly. It's just, I don't understand. Bad workflow is such a huge drag on productivity, but it's like, it's a coordination problem where not enough people get together and do the right thing to improve it. So I don't know. It's a constant tax that is so expensive. So expensive. Just don't look at Twitter all day. Yeah, maybe. That's right. Yeah, you can actually switch the compiler in Visual Studio to Clang now too. I'm not sure what the ramifications are of that in terms of debugging support and whatnot. Okay. So we've got this ident. We're emitting code for an identifier as an R value. This is all makes sense. Okay. It is a constant declaration. So now this decal that we're looking at is this one for foo, right? So if I go decal identifier name foo. So we're saying, okay, what happens when you evaluate a procedure that's a constant like this, right? And so follow the imports and okay. We're back here where we just were, but now it's no longer an identifier. It's a lambda. Good. Get current block. Plug register. Now this is going to be interesting. I should maybe start writing down some information. So if I want to get back here, lambda, the lambda serial number is oh God. 100000556A. See, a super useful thing in Visual Studio would be just like, oh, just make a note of this. Put it down on the bottom somewhere. This number is important, right? You can't do that as far as I know, and if you can, it's inconvenient. I mean, I can do this, right? But then it's like, okay, what was that value? Can I comment after it? No. I mean, I guess I could do this. Whatever. All right. So if we want to get back here, where we're generating code for this expression evaluation, but I don't think this is where the problem is going to be, but it could be. So what register number is this? This is a bytecode register, right? Not a machine register. Output into register OX1C. Okay, so we run an assign to function pointer. Assign to function pointer. Get rid of all the stupid zeros. That would be the one, if anybody asked me what one thing would you change in Visual Studio, I'd get rid of all the stupid zeros in 64-bit. Oh my God. You guys, obviously, where you guys are Microsoft, have no idea how much this impacts readability when you're trying to read through a lot of data structures. They don't care. They don't give a crap. All right. Or at least if you want to print them all, like gray them out or something. But like I can see an argument for like, we want numbers to be aligned. Well, just align it, put spaces. Who cares? Just don't. All right. So, yeah, I don't want to make debug visualizers for my structures. I just want the debugger to be good to start with. I don't want to have to write a debugger for my debugger to be good. This is what people don't, debugger developers don't seem to understand. Like, it's fine to let me write visualizers, but I shouldn't have to do that. I shouldn't have to do the debugger developer's job. You know what I'm saying? Okay. What I'm doing today is I'm fixing a stupid bug that is not the bug that I set out to fix, but that's okay. All right, so basically when we are doing this, so the placement thing says, okay, we know we're assigning this to a declaration in local scope. And that declaration is already going to have stack space and a register, so use those things instead of creating new ones, because that prevents us from having to also make a copy later on, which reduces the number of bytecode instructions that we generate. So, well, let's just keep stepping and see how things go. Okay, there is no stack allocation for this guy. So we don't do anything, right? So he's only in a quote-unquote register. Okay, so we're done with that. We emitted the code for the expression. We're done with that. We're done with that. We're done with the ident. We're done with that. Okay. Okay, so theoretically, value register 4. And then, so if we crash, then theoretically, it should be register 4, unless we're doing something else that has a register copy. Well, let's just step into the next thing since we're nearby. So we're finishing that statement. Okay, so the statement we just finished was this. And the next statement is this procedure call, which is good because that's what we want to debug. We want to make sure that this part gets the right value. So I'm just going to single step. Whoops, I stepped past it already, I think. it arrow type block. Yeah. Whoops. Well, you know what? Let's just do this. So we return. This is breakpointing to emit code for that one declaration. So we're just returning from all that. Here we go. We're back at that loop. So we go next, and the next statement should be a procedure call, yes. So I don't know if you can read the tiny print, but the type is a procedure call. Okay, so I did it again. All right, but we're here. Expression S is this. So we're going to set a breakpoint here. Conditions expr S is equal to that. Stop, restart. Our first breakpoint is still going to be the old one. Why did that take so long? Okay. So we're emitting code for a procedure call. Right, we're going to go down into this switch statement. It's going to say a procedure call this. Okay. So we've got an expression. No substitution, right? That's not a surprise. It should be an ident. So proc expr type is indeed ident. What? Hit the wrong key. Okay. This should be null, right? It's null because our procedure call is proc of 5, and proc is not constant, right? It's a variable declaration. But that's just inlining checking anyway. This is not relevant to anything that we're doing. We're not doing a spread. I think no return values, right? No return values. Okay. It's an ident. So we don't find a constant replacement for it, right? This is just saying, oh, if it's an ident and we know what it is, just get that thing. I'm actually not sure. I don't want to edit the program right now to put a comment here, but I'm not sure that this if statement ever takes effect anymore. I'll make a note. BB CPP line 3868. Like, I think anything that's an ident that's constant would have been const substituted before this. And so I think this is old code, but we'll see. Okay. It is not a lambda, or not a known lambda, right? So we emit code for expression. It's an ident, right? So we're getting the R value for an ident. All this stuff that we just stepped through. And value register 4. Yeah, I mean, that's agrees with what we saw earlier when we stepped through. All right, so we're getting the right register for the value of the procedure. So now everything else in this procedure doesn't matter because this is just going to be setting up arguments and all that. I mean, unless we break proc register somehow, but oh, well, okay, here we go. So the type of the lambda goes in here, and the options goes in here, and this bytecode serial number is 1CD8. And I think this is the one that will crash, right? So if I run ahead and crash, It should be one CD8 that crashes. So, you know, this is going to be like all this extended debugging for like what the problem is going to be something really dumb when it, yeah, this is how it goes sometimes. Okay, so proc register is 4. So I feel like when we crash, we're going to be looking in register 4, and the problem will just be that the value in register 4 will be wrong. So that I can come back here. So hardened procedure call. Well, no, for procedure call. So call arrow s is this. Okay. So I feel like I should have seen the problem in all that stepping that I just did, and I didn't see it. So I'm going to run ahead and make sure that we crash in the right way. Oh. What? I mean, this is interesting. It's a string this time, that's why we didn't crash. So we're getting like a random different register. Value. Okay, this is confusing me. Because that's supposed to be the value register for that declaration. If that's the value register for that declaration, why is it being used for a string? It's supposed to be unique. Man. Okay. Let's look. So we're pretending to be a CPU here. Let's go to this window. So our program counter is 1A. And so I can say, what's the instruction before this? 1, 9. Okay, assigned a function pointer. So like this, even if the register was being used twice, the instruction before this should have stopped it. Okay, this says put the result in 1C. Right, the result is, so this is not good. So it put the result in a different register than the one we're trying to use, is what's happening. Why? Well, now we're in the home stretch because, well, I mean, I guess, didn't we already set a breakpoint on this one? There's probably a different instruction. Well, whatever. Assign to function pointer. Instruction. Okay, so we'll break when BCS is equal to this. If we didn't have frickin' what do you call it? address space layout randomization, I wouldn't need all these serial numbers. I could just break on the memory address of all this stuff. But of course, everybody hates programmers and wants to make our life harder, even though that then makes all software lower quality when you do that. And so I have to add all this tracking data. That slows the compiler down as well, by the way. Thank you. Okay, so we're assigning a function pointer. Right, this is this thing. So the result is 1C. Why is it 1C? Look, it's a code merge bug or something. Look, see this result? Oh my God, I could have seen that if I was actually... So people have different debugging styles. My debugging style is never, and maybe it should be sometimes, but it's never to look carefully at lines of code and logic through them in my head. Almost never, until I'm very pinned down a problem. Because I'm more like, I just kind of know what the code does and it's in my head mixed around, and then I just kind of solve things kind of by intuition usually. This is obviously stupid. Look, I'm getting whatever the register placement wants, which is telling me register 4, as we saw, but then it's like, oh, let's stomp that by allocating a new register for the result value. What's going on is, before I put in this placement optimization, it was always just this, and you would always make a new register, and then that would be copied, and I was like, oh, add placement, and then I didn't test it. So the fix is delete that line. Right, so run. We're going to skip all our breakpoints, and hey, look, we didn't crash. So that was like an hour long of debugging for, if I had gotten to that part and just my brain had absorbed what the text says. Basically, I never look at what the text says. Whoops, that's Sokoban. I don't want to do Sokoban. I never look at what the text says when I'm debugging, and many times I find that maybe I should have, but then maybe I solve other things faster. Okay, so foo is fixed, right? Where's our foo 5? It should be here somewhere. There we go, foo 5. So let's then see. Let's get rid of this, and let's see if the bake, it works. Look, the whole program works. So the only thing we had to comment out was the SOA thing, right? Everything else works. Yay. Update the poly test and fix a dumb bug in register placement for procedure calls through for non-constant procedure calls. Well, that was not at all what I wanted to work on, but it's going to be time to take a break. I have to ease into it because, like I said, my brain is a little bit mush. I'm going to come back a little later today and do the polymorphism cleanup now that we have the demo working. Any questions before I do that? Any final? Breakfast. It's time for me to get some lunch. Lunch time. Yes, question. What's the question? Don't type yes, question. Where'd I get my shirt? This is from Nordstrom in Seattle. SpaceX launch. Okay, cool. Everybody watch the SpaceX launch. How this type of generics allows an implementation of a type-safe list T, for example. It just does. I mean, this is the same. it's a more powerful version of C++ templates that just has none of the bad properties, right? So I can go, so here's an example of a thing that I demoed way back. You can watch some demos with data structures like this. So this is a bucket array, which is like a more complicated version of a list where there's separately allocated things, and you pass the type as a parameter to the struct, for example. That's one way to do it. So structs have parameters that are constant at compile time, and that's how you would implement a data structure thing, right? Does this language have destructors? We'll talk about that in a week or two. The answer used to be that it does not have destructors. That may not be a correct answer anymore. All right. So I think that in the long-term sense, meditation is actually super valuable for my being able to program well. And I actually I'm going to do a little live streamed talk at some point, probably in the next few weeks, about that. That gives more details. Yeah. Why add destructors? Defer is all you need. I will explain why in a week or two when I do the demo. There's what I think is a pretty reasonable reason to add them. All right, guys. I'm going to stream again in a few hours or a couple hours or who knows what. Thanks for coming. See you later. See you later.